Namaste. Grade 10, Subject Science and Technology, Unit 15, Chemical Reaction. We are here to discuss first lesson of this unit. Dear students, we have seen different type of changes in our surrounding. Think once, what type of changes do we observe in our daily life? Yes, different changes we can observe in our daily life. Look at this picture. What is the picture related for? Yes, there is one mountain covered by snow-filled Himalayas, and the snow are melting to flow glacier. Do you know what type of change is it? Think properly. Similarly, there are other barrier changes. Look at here. A burning candle is there. Candle is burning. Do you know how candle burns? What is there in the candle? And what do we get after burning the candle? There is also change. Similarly, look at here. Boiling of water, boiling of milk, cooking rice, burning fire. Isn't it? Firewood burn fire. That means fuel can burn. Yes, these are also the changes that occur in our surrounding. Similarly, look at this picture. What's about it? Yes, it is a plant, green plant. It is a living being. And do you know what is the picture related for? Sure, it is about photosynthesis process. Do you know what is photosynthesis? Photo means light, synthesis means combination or chemical reaction in the presence of light. That means green plant utilize sunlight to manufacture food, isn't it? To manufacture food using mineral, water, carbon dioxide, isn't it? So it is also a type of change. So what type of change are occurring in our surrounding? Other changes are also there. Look at here. Here is a rock. Rock is splitting. Look at it. There is a crack. We see crack on the rock. What type of change is it? Similarly, look at here. Inside our body, there is also a complex process. Do you know which system is it? Definitely, this is digestive system in our body. How digestion occur in our body? Yes, there is also change. So, talking about the different changes in our surrounding, do you know there are mainly how many type of changes? Two types of changes that occur in our surrounding. What are they? Sure, these are physical change and chemical change. Dear students, what is physical change then? Look at this picture. This is an example of which change? Physical change. How can we say this is physical change? Look at it. This is ice. After melting ice, it changes into water. Water changes into vapor. That vapor has converted into cloud, isn't it? By cloud, rainfall occur, and again the cycle continues. That cycle is water cycle. Now then, how can we illustrate this process of change? Look at here. Ice converts into water. How it is converted to water? By heating. Ice is heated to change into water. Similarly, if water is heated, then what happens? Sure, if water is heated, then it changes into vapor, which is seen here in the picture. And reversible process also we have to understand about it. Reversible process means if vapor is cooled down, then what happens? Change into water. Sure, we have done different practical activities in our daily life also, right? Isn't it? Boiling water can be converted into vapor. Vapor can condense into water again. And if water is freeze, cool down, it converts into ice. So these are the three states of water: solid, liquid, and gas. Do you know? Remember, water has three states, isn't it? One state is ice, another state is water, then vapor. Do you know? Yes. When we heat, it changes into water. Ice is heated to change into water. Water is heated to change into vapor. But do you know one thing? Is there any change in the chemical structure, chemical composition of ice, water and vapor? Do you think that? What is the formula of ice then? Chemical formula of ice is H2O. What is the chemical formula of water? That is also H2O. And vapor? Yes, that is also H2O. That means there is no any change in chemical composition, chemical structure, isn't it? So, this type of change is physical change, just change in state. State means this is solid state, this is liquid state, and this is gaseous state, isn't it? Just state change, color change, size and shape change, these are the physical changes. Look at it. Ice is also denoted by H2O in chemical formula. Water is also denoted by H2O. Then vapor is also denoted by H2O. So this type of change is which change? Physical change. Then, dear students, the melting of ice is a physical change. Then look at here. Here is a burning of fire, isn't it? Fire can burn. Remember, we can do this type of activity in our daily life. Look at here. I have a piece of paper and look at it. This paper is burning. Do you know what happens? Do you see? Yes, smoke is producing. And what do you see here? Yes, here is a black charcoal, isn't it? If it burns completely, then we can see white color, brownish white color, ash, isn't it? Look at it. So this is changing, isn't it? This change is what type of change? Can we reverse it back to the paper again? No. Yes. So this type of change is chemical change. Chemical change is irreversible change, which cannot be reversed back to its original position, isn't it? Here is burning of firewood. Firewood burns to change into smoke, charcoal, ash, isn't it? And together with that change, we can get heat and light also, isn't it? It can release energy also. So this type of change are chemical change. Now, if we understand about the chemical change, then we should think what is chemical reaction. Think properly about chemical reaction. What is the relationship between chemical change and chemical reaction? Yes, what is chemical change then? You know, chemical change is a permanent change in which new substance, new product with different properties are formed. Just we have done simple activity. When paper is burned, it converted into smoke, charcoal, ash, and heat and light energy are produced. So this kind of change is chemical change, and this is also an example of chemical reaction, because while forming chemical change, there involves chemical reaction. So chemical reaction or chemical change is a permanent change. Let's discuss about some of the changes that occur in our daily life. Look at it. What do you see? A burning candle is there. How candle burns? And what change takes place there? Do you know? Candle goes on melting. Here are two changes in burning candle also. Look at it. I have also candle. This is burning candle, and if candle burns, then we can observe two types of changes. Look at it. This candle is melting. Do you see it clearly? Sure. The melting drops. When candle is heated, look at here, it melts, and the melting candle can be condensed back to candle again. The chemical composition is not different, but look at here, this candle does not remain constant for a long time, because it goes on it goes on reducing. How does it reduce? Yes, here is carbon, oxygen, hydrogen and other chemical compound, because candle is a product of petroleum product. So it has hydrocarbon. Hydrocarbon has inflammable property, that means it can burn, ignition, it ignites, isn't it? So it goes on finishing. After burning, it changes into carbon dioxide, isn't it, and heat energy. So here is also chemical change. Look at it. Here is chemical change and it is melting. There is physical change. Physical change and chemical change, both process we can observe by observing burning candle. Dear students, let's discuss. Yes, here is a fire. Burning of fire is also another example of chemical change. Let's discuss some of the question. Burning of firewood or fuel or candle to get heat is an example of chemical change. But how is it possible? Yes, it is possible because of chemical reaction. Do you know? The chemical substance present in the fuel can change into another product, isn't it? So it is possible due to chemical reaction. Rusting of iron, how does it rust? How iron get rusted? Do you know? There is also chemical process. Iron plus oxygen in the presence of moisture, it changes into iron oxide, that is hydrated ferric oxide like this. Iron, when it is left overnight in the moisture and air contains oxygen, then what will happen? It gets rusting of iron. And how can we demonstrate? There is chemical reaction like this. Iron means Fe ferrum plus oxygen, O2, and in the presence of moisture there is H2O. Remember, H2O, X, H2O. X represents number of molecule, 2H2O, 3H2O, 4H2O, up to 10H2O it can be, isn't it? So this is moisture. H2O means moisture. So after reaction it will be Fe2O3 dot XH2O. Yes, this type of reaction is rusting of iron, isn't it? Rusting of iron involves this type of reaction. And when we balance the equation, look at here, 2 Fe2O3, here 2 3 are 6, 3O2, 2 into 2, 4. 4 Fe plus 3O2 in the presence of water or moisture, 2 Fe2O3 dot XH2O. This is hydrated ferric oxide. Yes, this is a oxide formation because there is iron gets oxidized in the presence of moisture or water vapor. So this is also a type of chemical reaction. And dear students, there is rusting of iron which we have observed here in the picture. And what happens when magnesium bonds in air? Magnesium, when bonds, here is in the picture, look at it, it gives white powder or white ash. What happens? In the air there is oxygen, magnesium plus oxygen, what will happen? Magnesium oxide, isn't it? That we will discuss in the coming lesson. Dear students, about chemical reaction, let's perform one activity again. Yes, this activity we have just completed. When paper burns, it changes into this type of form, isn't it? As charcoal, smoke and heat and light are also released as a form of energy. Then how it is possible? What change is it? Is it an example of chemical change, chemical reaction? Sure, it is example of chemical reaction. How it occurs then? paper contains cellulose. Do you know cellulose? Yes, this is a compound present in the plant because paper is formed from the plant, isn't it? So cellulose formula is C6H10O5, that contains carbon, hydrogen and oxygen, which bond to give as smoke and energy in the form of heat and light. So it is an example of which change? Chemical change. So it involves which reaction? Chemical reaction. So chemical reaction is a form of chemical change. Remember, chemical reaction is a form of chemical change in which new substances are formed, isn't it? It involves loss, gain or sharing of electrons. There are atom and molecules in the substances where sharing of electron, losing of electron, gaining of electron involved in the reactant and reactant so that new substance can be formed, isn't it? The reactant means this can be element or compound to form a new product. So chemical reaction occur by combining or decomposing or exchanging the ion. Combination of the substances, decomposition of the substances or by exchanging ion present in the reactants, isn't it? So this is the phenomena of chemical reaction which occur in different area, different places in our surrounding. Let's discuss about chemical equation then. We have understood what is chemical reaction. Chemical reaction involve chemical change, isn't it? But what is chemical equation then? Do you know? Chemical reaction is represented by a shortcut form of equation either by words or symbol or formula called chemical equation. Equation has two sides, left hand side and right hand side. What are there in left hand side and right hand side then? Yes, a chemical equation has two sides, reactants in left hand side and product are written in right hand side. Let's see some of the example of reactant and product. Look at it. Here is one word equation. When water is decomposed, it changes into hydrogen and oxygen because water is composed of hydrogen and oxygen. Its chemical formula is H2O. So that we can decompose, we can dissociate water into hydrogen and oxygen by a process. Do you know that process? Yes, that process is electrolysis process, isn't it? So which is reactant, which is product then? Try to identify. Yes, this is equation. This water is H2O and hydrogen is denoted by H2 in diatomic form. We don't write only H to write the chemical reaction, chemical equation. We write H2 because it is diatomic form that you have already understood in the grade 9, and O2 means oxygen. It is molecular form, diatomic form of oxygen. So here then it can be balanced because H2O equal to H2 plus O2. So equation was not balanced initially. So we have to balance like this, isn't it? H2 O is single in left hand side, O is double in right hand side. So to make it double, first of all we have to multiply the right hand side, left hand side by 2, then oxygen will be balanced. And now hydrogen has increased. How many atoms are there in hydrogen? 2 into 2, 4 hydrogen are there. So to balance it, we have to write like this, 2H2O equal to 2H2 plus O2. This is balanced chemical equation. Now, which is reactant, which is product? Do you know? This is reactant. Water is reactant because it is taking part in chemical reaction, isn't it? Which is written in left hand side of the chemical equation. And which is product? Yes, hydrogen and oxygen are the products, isn't it? One reactant, two products. Sometimes two reactant, one product also can be observed. Sometimes two or more than two reactant and product also can be involved, isn't it? So this is a chemical equation. It represents chemical reaction. Which chemical reaction? What happens when water is electrolyzed or water is decomposed? Water is broken down into hydrogen and oxygen expressed in chemical equation. We have to write like this. Look at here. This represents water. Do you know? This red color ball represents the oxygen and this white color are hydrogen, isn't it? H2O. It represents H2. How many H2O molecules are there? 2 H2O. This 2 H2O equal to, look at here, H2, H2. Here also H2 and O2. Yes, this is dissociation of water into hydrogen and oxygen. 2 H2O equal to 2 H2 plus O2. Look at here. What is the process shown here? Yes, same process of decomposition of water into hydrogen and oxygen. This process is called electrolysis because electricity is supplied here. Here is anode and cathode. There is water containing few drops acidified solution, and when current is supplied, then this water can be decomposed into hydrogen and oxygen, which is electrolysis process. You might have observed this in your science laboratory and science exhibition also. Even in grade 9 also you can study about it while lab preparation of hydrogen gas, manufacture of hydrogen gas and oxygen gas. So this is the process of electrolysis of water. Now another example, word equation, magnesium plus oxygen. What happens? Magnesium oxide. How can we write magnesium plus oxygen, magnesium oxide? You know, look at here, magnesium plus oxygen. Do you write only O? Never. We have to write O2 here because oxygen is diatomic form. We have to write diatomic form, and here is what will happen? MgO2. Is it correct? No, it is not correct. Then how to write? MgO, because magnesium valency is 2, oxygen valency is 2. So by crisscross method, its correct formula is MgO. But is it equation balance? No, because here is oxygen two atoms, here is only one atom. So how to balance it? Put here 2, multiply by 2. So oxygen is balanced, now magnesium also we have to balance. So magnesium plus oxygen, magnesium oxide. This is a chemical reaction which is expressed in equation form. This is left hand side is reactant, right hand side is product. So after writing the equation, it needs to be balanced. Some of the equations are automatically balanced also. Yes, we can symbolize or we can express in symbolic equation like this. Mg plus O2, MgO. Equation is not balanced, so let's make it balanced equation. 2Mg plus O2, 2MgO. So after writing correct equation, we have to balance the equation. Now about chemical equation, let's discuss about another example. Aluminum plus sulfuric acid, aluminum sulfate plus hydrogen. Do you know? Aluminum symbol is, do you know? And sulfuric acid, think properly. These are the reactant. Look at it. Aluminum and sulfuric acid are reactant. Then product are the aluminum sulfate and hydrogen. Now how can we express this equation in symbolic form? Like this. Look at it. Aluminum plus sulfuric acid, Al plus H2SO4, Al2SO4 whole bracket 3. That means sulfate radical has valency 2, aluminum has valency 3. By crisscross method, aluminum sulfate correct formula is this, and hydrogen gas is released. Dear student, the equation is not balanced. Do you know where is not balanced? Aluminum is not balanced. Look at here. Similarly, SO4 radical is not balanced. SO4 is triple here, here SO4 is single. Then how to balance? let's balance it like this. 2Al plus 3H2SO4. Look at it, 3H2SO4, Al2SO4 whole 3. Now hydrogen has also increased, so we have to balance the hydrogen also like this, isn't it? So reactant and product you understood clearly, and how to write the equation, then how to balance, that also you could know about it. Another equation let's discuss. Magnesium oxide, when magnesium bonds with oxygen, it gives magnesium oxide, we have just discussed. But if we react magnesium oxide again with water, then what happens? Yes, it gives another product, magnesium hydroxide. Now, how to write in the balanced chemical equation? Like this. Look at here, magnesium oxide, MgO plus water H2O, and its correct formula is MgOH whole bracket 2, because magnesium balance is 2, OH means hydroxide, hydroxyl group, its balance is 1. So its correct formula is like this. Is it balanced or not? Let's check it. Mg, its balance, oxygen, double oxygen here also, right, left hand side and right hand side, oxygen and hydrogen are double. So this is balance. Dear students, let's perform one activity. Write balanced chemical equation for the following. Yes, I am giving some of the question, some of the condition to you. You have to think how to write the balanced chemical equation. Look at it. The first question is, when zinc is treated with hydrochloric acid, think properly, zinc plus hydrochloric acid, that is the reactant side. You have to find the product. And another question is, when nitrogen combines with hydrogen, nitrogen and hydrogen are the reactants. Nitrogen plus hydrogen, what will be the product? You try to complete, and later on I'll facilitate you how to write. Third question is, when sodium reacts with the chlorine, how to write this? What are the reactant? Sodium plus chlorine. Yes, let's discuss what is the answer in the first question. First problem, zinc is treated with hydrochloric acid. Zinc plus hydrochloric acid. Yes, dear students, look at here. The equation is balanced like this, ZnCl2 and H2. H and Cl need to be balanced, so we have added here 2 HCl, isn't it? Answer of second problem is, when nitrogen combines with hydrogen, how to write this? We can write like this, nitrogen plus hydrogen equal to ammonia. Ammonia is product. Nitrogen and hydrogen are reactant. Look at it. Nitrogen is diatomic, so we write N2. Hydrogen also diatomic, we write H2, and ammonia formula is NH3. So to balance the equation, first of all, hydrogen need to be balanced. Look at it in right hand side and left hand side. So N2 plus 3H2, 2NH3. You try to balance this equation. Similarly, third reaction, we have to write chemical equation like this. When sodium reacts with chlorine, what happens? Sodium plus chlorine, the product is sodium chloride. So sodium is denoted by Na, chlorine is denoted by Cl2, and the sodium chloride correct formula is NaCl. So how to balance it? We have to balance like this. Look at it. 2Na plus Cl2, 2NaCl. Dear students, let's discuss some of the symbols used in the chemical equations, because how to write chemical equation we learn about it, but some of the symbols are there which we need to add, we need to mention to represent their physical condition and other states. Look at here. The first symbol is this plus. What is called this? This represents separating two or more than two reactant or products, isn't it? Two or more than two reactant and product can be represented by this. Look at here how equation can be separated like this. Two reactant are separated by plus sign, and two product are also separated by plus sign, isn't it? Separating 2 or more than 2 reactant or products. This is arrow. Look at here, arrow in one direction arrow, unidirectional arrow represents the irreversible, that is forward reaction, and also denotes the direction of the reaction, in which direction reaction is going on. Similarly, look at here, two-side arrow, left and right side, the arrow pointing to side, this is irreversible reaction. That means reactant and product can be reversed. They are reversed back. Similarly, look at here, S alphabet within the bracket represents solid. Look at it, in this reaction, where is S? This zinc is solid, isn't it? We can represent this in the symbol S. It represents the solid state for the reactant or product. Similarly, L. Within the bracket there is L, small l denotes what? That denotes the liquid state, for the reactant or product. For example, water. If there is water, then we can denote it by L. Similarly, G represents the gas, isn't it? Gaseous state of the reactant or product. In the above equation, look at here, H2, we can put there G also, isn't it? G means hydrogen is in the gaseous state. Similarly, look at here, AQ. What is AQ? AQ means aqueous solution. Aqueous solution means the substance is dissolved in water, isn't it? Look at it. Here is HCl is aqueous. That means hydrochloric acid is not pure here. It is water soluble form, isn't it? Aqueous solution of hydrochloric acid. Similarly, ZnCl2, zinc chloride, is also denoted by AQ here. Similarly, look at here, vertical arrow. What does this arrow represents? Yes, here is, look at it. H2 we can represent by this vertical arrow also. That means gas. It indicates gaseous product or formation of the gas during chemical reaction. Similarly, another symbol is down arrow. Look at it. Down arrowhead represents the precipitation or PPT, or product is insoluble or a solid. Yes, let's see one example. In the reaction between silver nitrate and sodium chloride, look at here, it forms silver chloride and sodium nitrate. But silver chloride is insoluble, it is solid. So it can be represented by S as well as down arrow too. Look at it. So this type of product or reactant can be represented by this arrow. Similarly, look at here, this one symbol, triangle like symbol, that is delta, it represents thermolysis reaction. That means it indicates heat applied for the reaction, isn't it? And another symbol is, look at it, there is arrowhead and there is written electricity, that it represents electrolysis, means dissociation of reaction by passing electricity. Similarly, look at here, arrowhead, and above the arrow there is HB. HB denotes photolysis. What is the meaning of photolysis? That means some of the chemical reaction need light to occur, isn't it? Some chemical reaction can occur in the presence of light, that is photolysis reaction. And look at here, there is some of the substances are denoted like iron, platinum, and other substances can be placed here above arrow. That is catalysis, means catalyst is used for the reaction to occur, isn't it? If reaction need catalyst, then this type of symbol can be used. Similarly, look at here, above arrowhead there is certain temperature in degrees Celsius. It denotes the temperature required. So temperature required for the reaction, isn't it? Some of the reaction can require temperature, or temperature can be given. Look at it, above the arrowhead there is ATM. ATM denotes the pressure, isn't it? So it indicates pressure that is needed for the reaction to occur. So we can use some of the symbols like this while writing chemical equation. This symbol can show the clear effect whether the reactant or product are in solid, liquid, gas or solution form, isn't it? Their physical state can be expressed. Dear students, now we are going to discuss some of the question, isn't it? That is multiple choice question. Let's think. The first question is like this: which of the following is correct equation for the reaction when magnesium bonds in air? Magnesium bonds in air, we have already discussed magnesium plus oxygen, isn't it, equal to magnesium oxide. That is the correct chemical reaction, isn't it? So we have to express it by chemical equation, and here are some of the equations you have to find out the correct form. Look at Mg plus O2, MgO2, or 2Mg plus O2, 2MgO, or 2Mg plus O2, Mg2O2, or 3Mg plus O2, Mg3O2. Dear students, let's find the correct answer. Here, you have already found what is the correct answer. Let's check it. Yes, 2Mg plus O2, 2MgO. This is the correct equation for the above chemical reaction. Second question is like this. Question number 2. Which of the following is correct to complete the equation? Look at here. Here is one equation. 4Fe plus 3O2 plus XH2O equal to, what will be the product? Remember, iron plus oxygen in the presence of moisture. I have already explained about it. Try to find which is the correct product of it. Is it 2Fe2O3 or Fe2O3 or Fe2O3 dot XH2O or 2Fe2O3 dot XH2O? Which one will be the correct form, correct product? Did you find? Sure, let's check it. This is the correct form of this equation, 2Fe2O3 dot XH2O. What is the reaction related to? It is related to rusting of iron, isn't it? Rusting of iron occurs like this. Now let's discuss about question number 3. Question number 3 is like this. What is called the reaction that require light to occur? Remember, light to occur. Is it thermolysis, electrolysis, photolysis, or catalysis? Did you know? Let's check it. Yes. Sure, this is photolysis. Means some of the reaction require light. That is called photolysis reaction. Dear students, in today's class we have discussed about chemical reaction. Chemical reaction is a form of chemical change. And how to express chemical reaction? We can express chemical reaction in the form of chemical equations. How to write chemical equation? Chemical equation can be written in two ways: word equation and symbolic equation or formula equation. Chemical reaction or chemical equation has two sides, reactant and product. So after writing chemical equation, we have to balance them, isn't it? Left hand side and right hand side, or reactant and product must be balanced. Together with, we have discussed about the various symbols used while writing chemical equations. Yes, today's class is over. Its remaining lesson we will discuss in the coming class. Thank you. Namaste.